Hello, ladies and gentlemen. Today we're going to talk about angles and circles. So the angles inside of a circle, you're going to need a foldable. You're going to want something to write with and potentially even a calculator. So we've already been talking about this thing called a central angle. So let's get a definition written down for that. So the central angle, the actual definition for that is an angle that has its vertex at the center of the circle. So we already knew that, and you already have this picture in your note, but let's label this picture. That central angle is going to be in the center, composed with the center of the circle. Okay, and all this is saying is that the measure of angle C, so the measure of this inside angle is going to be congruent to the measure of the arc. So congruent to the measure of the arc. The angle, when it's a central angle, is congruent to the measure of the arc. So along with your foldable, you should have gotten a half sheet of paper. Okay, on this half sheet of paper, this is where we're going to keep track of all our formulas for circles and the angles within a circle. So the first thing we're looking at here is when angles are formed by two radii. This is what we just talked about. So if we kind of sketch ourselves a picture here, sketch yourself a picture. Okay, draw in two radius, one radius there, one radius there. It's saying that when your central angle is formed by two radii, the measure of the angle, so the angle here, is going to equal the measure of the arc. Okay, so we're just getting that jotted down. That's something we just talked about. We learned about that a while ago. We aren't necessarily to an angle formed by two chords, so we're going to skip that one for now, but we'll come back to it very soon. So yesterday we talked about the central angle and how the central angle, this bear right here, the measure I had here was the same as the measure on my arc. So today I'm going to challenge you in what happens if I take that bear and I pull it back. We imagine that these radius or these radii become a rubber band, and what if I pull it back like I'm ready to launch it? Okay, like we're launching the teddy bear. Like what happens to that angle? Notice the angle formed by these two lines then gets a little bit smaller than it was when I originally started, because when I grab that rubber band, when you pull it back to release it, the angle between the rubber band is getting smaller. So today we're going to talk about the actual equation for what happens when we do that. So before we get into any examples, we're going to talk about the actual formula we're going to use for this. So when we talk about an angle and its intercepted arc, we first have to understand the vocabulary here. So when I say an inscribed angle, so that's going to be an angle inside the circle, but what's important is the vertex of that angle, the point of that angle lies somewhere on the circle. So here I have that point. We'll mark it up here in red. But that vertex has to be somewhere on your circle for it to be an inscribed angle. So when it's on my circle like that, then we have an inscribed angle and we also have an intercepted arc. So the arc across from that angle then is still going to be considered my intercepted arc because it's what's covered by those two line segments or rays that make up my angle. So that is my intercepted arc, what is between the rays that make up my angle. Okay, so then if we try to figure out what the formula is going to be for this, then if we take this example, we could probably figure it out. Now looking at this example here, how many degrees is the intercepted arc? And does that help me figure out how many degrees the angle would be? So let's just look at this intercepted arc here. So this intercepted arc looks like it's going to be about half of a circle. And so when we think about the measure of half of a circle, we know half of a circle is 180 degrees. So the intercepted arc is going to be 180 degrees. Now, when we look at the angle formed in red, then how does the angle, since the intercepted arc is within this angle, what would you assume that angle would be? I'm sure just by looking at it, you're thinking, well, that looks a lot like a right angle. And as a matter of fact, it's going to end up being a right angle. So it looks like then that the angle we are dealing with here is going to equal 1/2 of the arc, because if we look at 180, we know that 90 degrees here is exactly half of that. So let's also write that down. We just discovered that the measure of an inscribed angle, so an angle whose vertex is on the circle, equals half of the measure of its intercepted arc. So looking here, we have a picture. Let's get that jotted down. Okay, the measure of an inscribed angle, so measure of ADB, is going to be 1/2 the measure of its arc. So an angle inscribed in a semicircle, just like we found out, is going to be a right angle, because remember, this is a vocab word. Semicircle just means half circle. Okay, so again, one more time, the measure of an inscribed angle equals half the measure of its intercepted arc. Going back to our formula sheet then, here let's get some more written in. Now we know if I have two chords, okay, again, a chord is something whose endpoints are on a circle. Okay, so let's draw in a couple chords here. Endpoints again are on the circle. Okay, so we just realized that when we have an inscribed angle like this, we found out that the angle is going to equal 1/2 of the arc. Okay, and we haven't quite yet talked about this next one, tangent and chord, but we could get it jotted down. If we draw in here a point of tangency, and then we draw in our tangent line, okay, now when a chord forms an angle right there, again with that vertex being on the edge of the circle, okay, this angle right here is also going to be 1/2 the measure of the arc. Okay, so again, when you have a chord that meets a tangent line at the point of tangency, that angle formed by the two is going to be 1/2 the measure of the arc that is between it. All right, let's look at this first example then here. So it looks like we need to find the indicated measures in circle C. The first thing we're expected to find here is the measure of angle D. So if we're looking at the measure of angle D, that's this angle right here. Okay, and if you look at D, it looks like it's comprised, or it's made up of two chords. And again, if we look at that formula sheet, if I have two chords, we know that the angle that is formed by two chords equals 1/2 the measure of that arc. Okay, so if we're looking here at the measure of the arc, then the arc that is inscribed or intercepted by angle D is the arc E to B. So the arc there is 100. So if we're thinking about plugging in 100 there, thinking about that, what would be 1/2 of 100? Well, 1/2 of $1 is 50 cents, right? So 1/2 of 100 is going to be 50 degrees. Okay, so that measure of angle D is going to be 50 degrees. Now next, it looks like we're supposed to find the measure of arc A. This is supposed to be D, so it should be arc A to D. Make sure you get that switched there. A to D. Okay, so that means we're looking at this arc right here. So in order to figure that out, we have to use the angle that intercepts that arc, so the angle 35. And we know that the angle has to be half of what the arc is. So if 35 is my angle, that means I should probably double it to get my arc. So if I take 35 and I double it, again, we could use this same equation. We could say the angle has to equal 1/2 of the arc. You don't necessarily have to, because I think you could do some of this with mental math. Okay, so then the angle then is 35. We don't know the measure of the arc, so that would be x. In order to solve, we'd multiply both sides by 2. These would cancel. I would get 70 equals x, so it looks like the measure of the arc is going to be 70 degrees. If that doesn't make sense, make sure you star this so we can answer questions. All right, so looking at this next one then, I have a couple questions I want to walk through. I want us to compare the intercepted arc for angles J and angle K. So let's look at these quickly. So if we're looking at angle J, here is angle J. When I reach out my lines, or I draw out my angle, it looks like the arc across from J would be M to L. Okay, So similarly, let's look at angle K. And angle K is this angle right here. That's a terrible color. Let's change that color. So this angle right here, this is going to be the angle that is, I'm outlining it in red. And if you notice there, again, the arc for K looks like it's going to be ML. So what can you say? It looks like if they have the same arc, then the angles look kind of similar. But let's take a look at another example then. What if we look at the angles L and M? So again, if we're looking at angle L, that's this angle right here. And if I look at angle M, it's this angle right here. But again, the arc that they both share is J to K. And if they have the same arc, again, that must mean that these angles have to be the same because the angles have to be 1/2 of its intercepted arc. So therefore, M and L would be the same. So what are the conclusions we might be able to make here? It looks like that if we have two inscribed angles in a circle that intercept the same arc, the angles that are intercepting that arc have to be congruent. That only makes sense if they share the same arc, correct? So let's make sure we jot that down, get that starred so we know that it's very important that we can have congruent angles within the same circle that share the same arc. So looking at our last example then, we want to find the measure of angle, or the measure, excuse me, of arc K to N. So that's K to N here. And it looks like K to N is intercepted by angle L. So yet again, we know that angle L, so the angle, since it's formed by two chords, the angle has to equal 1/2 of the arc. So again, we know the angle is 52, and do I have to do this mathematically? Probably not. Some of you can just look in your head, or think in your head, okay, well, I just have to double 52, and if I double 52, then I would get my arc length. So if I solve then, to get rid of these 2's on the bottom, it looks like x is going to equal 104. And x in this instance stood for the arc K to N. So K to N is going to equal 104 degrees. Now the next thing we want to find is the measure of angle KMN. So KMN. But if you look at KMN then, the arc length that we just found for Kn is going to be the same thing because M shares that same arc length. So again, K to N is 104, and in order to figure out this angle M, we need to take 1/2 of 104, which we should already know is going to end up being 52 degrees. So the measure of angle KMN is 52 degrees. Again, using those formulas, knowing that these chords are intercepting the same arc, that's the reason they're going to end up being the same. Okay, I want to thank you for taking good notes. If you have any questions, make sure you jot those down so we can address them in class.